Good morning, children. Today we are going to discuss a chemistry practical lesson. Okay, this year you have 3 practicals only. Some of the practicals are already omitted from your portions. Okay, so we are going to discuss the aim, the procedure, and the inference of practical number 1, which is study the properties of acids and bases. Okay, so I'll show you the experiment also. So everything is like a real practical but on a virtual platform. Alright, so here is the first experiment. Study the properties of acids and bases. Okay, here aim. To study the properties of acids and bases, we are taking hydrochloric acid and sodium hydroxide by their reaction with red and blue litmus papers, zinc metal, sodium carbonate. Okay, so we are going to study the properties of hydrochloric acid and sodium hydroxide by using some of the substances like red and blue litmus papers, zinc metal, sodium carbonate. Okay, here are the materials required: test tube stand, hydrochloric acid, sodium hydroxide solution, litmus papers, zinc metal, sodium carbonate, distilled water, lime water, etc. Alright, here is procedure number 1. So, reaction of acid and base with litmus papers. So, what is the first step? Take about 20 ml of dilute HCl in a test tube. Okay, then put 2 to 3 drops of HCl on a blue and red litmus paper strips. Observe the color changes. Okay, and repeat the same procedure for sodium hydroxide solution also. So here we are going to see the experiment. After that we will write the observation. Okay, here you can see hydrochloric acid and sodium hydroxide solutions are taken in 2 beakers. Okay, and she's taking a red litmus paper and she's dipping that in hydrochloric acid. Now color change is observed. But when she dipped in that sodium hydroxide, it turned into blue. Again, when she dipped in hydrochloric acid, it turned into red color. So in the experiment, what did you see? What was the color change observed with blue litmus paper? When we add hydrochloric acid, we have seen that blue litmus paper turned into red color. Okay, and there was no color change for blue litmus paper when we added sodium hydroxide solution. It remained as blue itself, right? Okay, what about red litmus paper? When we added hydrochloric acid, there was no color change, but when we added sodium hydroxide, red litmus paper turned into blue color, isn't it? So this is the observation table. Okay, so we are moving to the second one, that is reaction of acid and base with zinc metal. Here is the procedure. Take few granules of zinc in a test tube, then add some dilute HCl into it. Now you can see a vigorous reaction in which bubbles of a gas is evolved very quickly. So observe the color and odor of the gas evolved. Okay, and repeat the same procedure for sodium hydroxide solution also. So in the case of sodium hydroxide solution also, you can see the same reaction when we add some zinc metal. To identify the gas, bring a burning candle near the mouth of the test tube. So shall we move to the experiment? Okay, come on, let's see the experiment.
Hello scientific brilliant people, how are you today? So today I'm going to demonstrate another chemical reaction. This is the displacement reaction between zinc and hydrochloric acid. Actually this reaction can be carried out with dilute hydrochloric acid as well, but I'm going to use the concentrated hydrochloric acid to show more of its effect. Now as you can see that I have some zinc metal granules over here, and it is silver in nature, very light. Actually it's a dense metal, but I have a very small lighter piece of zinc and in this watch glass, and these are the zinc pieces. And now I need not to show you this in the later part of the video. And what else things are required for this experiment are: you require a candle, matchstick box, you require hydrochloric acid concentrated, stand, test tube. There are already few pieces of zinc inside, and a test tube holder. You also require a dropper in order to put this concentrated hydrochloric acid into the test tube. So let's begin the experiment, people. So now I have this test tube which already has few zinc granules, and I have rigidly fixed this test tube on the stand, and now I am going to add the concentrated hydrochloric acid, and you will see that the bubbles of hydrogen will immediately start to come out. And guys, we also know that hydrogen gas is a flammable gas, and hydrogen burns with blue flame and hydrogen burns with pop sound. So I will try to show you the blue flame. It is a bit difficult to see this blue flame because it is very light, and the pop sound can be well illustrated from this demonstration. So let's begin. So I'm going to take, it's very dangerous for me to do this, this hydrochloric acid. I'm going to take some HCl, and then I'm going to put back the hydrochloric acid, and I'll make sure that the lid is being properly closed. Now this is the hydrochloric acid, and I'm going to add this. So as you can see, the reaction is very vigorous.
Here is the observation table for the reaction that we saw just now. Okay, serial number 1, experiment. Color and odor of the gas evolved with hydrochloric acid and with sodium hydroxide. In both the cases, a colorless and odorless gas is evolved, isn't it? Then, what happened when bringing a burning candle near the mouth of the test tube? So, in both the cases, it burns with a pop sound. Okay, this is the observation table for the reaction of metal zinc with acid and a base. Okay, here is the last procedure. What is the reaction of acid and base with sodium carbonate? Okay, now take some sodium carbonate in a test tube, add some dilute HCl. Okay, then you can see a vigorous reaction. Very quickly bubbles of a gas is evolved. Then you have to observe the color and odor of the gas evolved. Okay, and to identify this gas, pass the gas through fresh lime water. What is lime water? Lime water is calcium hydroxide. And observe the changes and repeat the same procedure for sodium hydroxide solution also. Okay, so let's move to the experiment now. Remember, with sodium hydroxide, sodium carbonate will not show any reaction. Only with acid, sodium carbonate react vigorously to form carbon dioxide. Okay, so let's move to the experiment. After that, we will fill the observation column too. Okay.
you need to know how to test for a number of different gases in your GCSE. This comes up all over the place in the GCSE, and this is the test for carbon dioxide. And hopefully you can see that the lime water is starting to go cloudy. This is because the lime water is calcium hydroxide. As we add the carbon dioxide into it, it turns into calcium carbonate, which is the cloudy precipitate that you can see.
So, from the experiment, we can fill the observation table now. We observe the color and odor of the gas evolved, isn't it? With hydrochloric acid, a colorless and odorless gas is observed. And for sodium hydroxide, no reaction happened for sodium carbonate. Okay, now what happened to the colorless, odorless gas when it is passed through lime water? What happened? Lime water turned milky white, isn't it? So which gas is present here? Presence of carbon dioxide gas is identified. Alright. So here comes the end of the procedure and observation table. Now we have to conclude by writing the inference or the analysis, isn't it? So here is the inference. Okay. So all the cases with chemical equations we have written here. In the first case, we understood that acid turns blue litmus paper red and base turns red litmus paper into blue color. Okay. In the second experiment, we have understood that zinc granules can react with acid as well as base to produce hydrogen gas. In the case of hydrochloric acid, what happened? Zinc chloride and hydrogen gas are produced. Okay, and in the case of sodium hydroxide, when it reacts with zinc, a salt named sodium zincate and hydrogen gas are evolved. Now how to test the gas evolved? By bringing a lighted candle at the mouth of the test tube. So if it is hydrogen gas, it will burn with a pop sound. Okay, and the last experiment was sodium carbonate. The reaction of sodium carbonate with acids and bases. So we understood sodium carbonate reacts with acid to produce carbon dioxide. Okay, and there was no reaction with a base, right? So here, when sodium carbonate reacted with an acid, salt, carbon dioxide and water are produced. Now how to test the carbon dioxide gas? Pass through lime water, which is calcium hydroxide, isn't it? When carbon dioxide is passed through lime water, what happened? Insoluble calcium carbonate is formed. That is why lime water turned into milky white color, due to the presence of insoluble white colored calcium carbonate. Along with that, water is also produced. So hope you understood it very clearly. In between the theory sessions, we have to discuss practicals also. So sometimes questions from practical sessions are also coming for your exam. So go through the aim, procedure, observation table and inference very carefully and watch carefully the experiment I have included here. Thank you children. Thank you for watching the video. Have a nice day.